Okay, in this tutorial I'm going to talk about why it is that we put a standard ACL closest to the destination. So in this scenario right here, I added one more network up here. This is the 4 network up here, and the computer here is 4.100. The router is 4.1, and what I did was I added on this router here a static route to the 4 network so that these computers can ping 4.100. And you can see that if I open up a command prompt and I try to ping 4.100, you can ping 4.100, right? Okay, so we have connectivity right there. Now, in the last video, we applied a standard ACL, right? And we changed it to ACL 99, and that ACL looked like this right here, basically. We denied host 100 and we denied host 101. We changed the configuration from the IP address and the wildcard bits to just the IP address and the word host. So we denied 100 and 101, and I've put here deny, deny, and then we permit everybody else, which in this network would be this person right here, this computer right here, which is 102. So I put deny, deny, permit essentially, right? And we wanted to deny them from reaching the 1 network, which is over here, right? So if you put a standard ACL closest to the destination is here, and the interface is this interface right here, FA0/1, outbound, right? And so I wanted to set up a scenario to show you why we put it closest to the destination. And one of the best ways to show that is to add another network. So I added another Ethernet card to the router, and I added this 4 network, which is right up here. So now we have this 4 network Now we can, it's best explained why we apply it closest to the destination. So, and I'm going to show you why. So let's try something out here. So you'll see that on this router, I will essentially turn off our ACL by doing this. I'll say conf t interface FA0/1 no IP access group 99 out. Okay, and whoops, I need to put this command in. Copy. First I need to go into interface FA01. Okay, now I can put that in there. No IP access group 99 outbound. Alright, Control C, show run, and you can see that on FA0/1 it's no longer applied to the interface. We still have the access list here, but now it's going to no longer work. So now 2.100, instead of being denied, should be able to ping 1.100. And we'll just give it a quick show here. Alright, there's the reply. So now the access list is no longer applied to this interface, right? So what if we didn't realize that we don't apply the access list closest to the destination, right? Let's see what happens if we apply it somewhere else, like closest to the source, which would be this router, on the inbound interface on FA01. So we go to this router, and we have config mode here, global config mode, and we'll just copy this access list. All right, we'll say copy, and I'll just paste that in there. Access list 99, deny host 100, and then deny host 101, and then permit any. So now we've written the access list in the wrong place closest to the source, and we're going to apply it to FA01 inbound, okay? Because it's going from here into the router, so we have to do it inbound. So we'll say interface FA0/1 IP access dash group, the number of the access list, which is 99, and then we'll say IP access group 99 and then in. Alright, there we go. So now it's inbound. Now, our goal was to deny traffic to the 1 network, not to deny traffic to the 4 network. So as you can see, now if we go to 2.100, we can in fact deny traffic to the 1 network, which is great, right? Destination host unreachable. But we can no longer reach the 4 network. So the problem is that with a standard ACL, it only denies or permits the source IP address. So it's denying the 2 network, essentially, or denying these 2 hosts on the 2 network from going anywhere now. Now they can't go to the 1 network. Now they cannot go to the 1 network, and they can't go to the 4 network. But our intention was to just block the 1 network, right? So let's reverse that. We'll just put the no command in here. All right, we'll get rid of that. And we'll apply it in the correct place here, which is not here, because if we apply it here, let's say inbound, it'll do the same thing. It'll block us from both networks. It'll block these hosts from reaching both of these networks. So we have to apply it FA01 outbound. So we'll apply it correctly again. Conf T interface FA0/1, and then we'll do IP access group 99 out, right? And now, once again, it's been implied in the correct place, outbound here. So now we're blocking the source IP addresses 2.100 and 2.101, right, here from reaching this network, but they will still be able to reach the 4 network. Let's just test it out really quickly. And so there's the 4 network, and as you can see, we get a reply from 4.100, but when we try to reach 1.100, destination host unreachable. So that is why you apply standard ACL closest to the destination, because since you only can block a source IP address, right, you can't block a destination, you need to put it closest to the destination. Now, with an extended ACL, which I'm going to do next, extended ACLs are much more flexible because you can block the source and tell it the destination to block, right? And so with a extended ACL, we could say block 2.100 and block it from destination 4.0. So we could say we want to block 2.100 from reaching 4.0, or we could block 2.100 from reaching 1.0. So we could apply that ACL here because not only does it have a source to refer to, but it also has the destination to refer to. So it's placed closest to the source as opposed to the destination. So we'll do that. We're going to do extended ACLs in the next tutorial.